Hello everyone, my name is Caleb Redfern and I am an adjunct professor at CCSU teaching an Introduction to Manufacturing lab for engineering students. Normally we do a casting demonstration, but unfortunately this semester our foundry furnace was offline, so I decided to take matters into my own hands and just do it in my own garage. My friend Adrian and I have been working on a few projects together involving aluminum casting. We're working off of a book by a man named David Gingery, who at one point in his life built an entire machine shop completely from scratch. And then he documented the whole process so that it could be done again by nerds like me. So that's how I got into casting. The part that I decided to make for this is a CCSU logo. Now, I designed this pattern to be a little challenging to cast on purpose. There are several sharp corners around here. There are many internal contours that are very tiny, so I expected to get some problems from that. There are other things that I did more conventionally correctly, such as all the corners are radiused on the inside fillets. These ones are not, but these ones are. And all of the sides have a few degrees of draft on them so that you can extract the pattern from the sand more easily. Now, there are several things that I am doing differently than we would have done in the actual lab had the foundry been working. For one, I am using green sand, which is a mixture of sand, clay, and water as a binder. The clay just forms around the sand particles to make them stick to each other, and the water has to be at the right level in order for them to stick well. If the water level's off at all, you'll wind up with some weird quirks. In the engineering building, we have what is commonly known as Petrobond, which is a brand name for an oil-bonded sand. Oil-bonded sand is very useful for aluminum casting and other low-temperature alloys. You probably wouldn't want to use it for iron because the oil in the sand would actually light on fire, and, well, as hilarious as that would be, it wouldn't yield good results. So, green sand is still used in some parts of industry, as far as I'm aware. It's also much more accessible to the home hobbyist because you can make it yourself with a few dollars of ingredients from Home Depot or your local hardware store. I actually wound up doing this casting more than once. The first time, I got a relatively reasonable result with some of the errors that I anticipated, and this is the one that I showed to the students in my sections of the lab. As it turns out, someone may have pressed the take a picture button instead of the record button on the camera, who will remain nameless, and anyway, I did it a second time just now, earlier today, and wound up with this. A few different results, but let's dig into the process first, and I will walk you through everything that I did, and then we'll come back here and take a look at these in greater detail. Step 1 for this process is to fill up a crucible with aluminum stock. I'm using previously cast ingots from other melts. Step 2 is to get the fire up to a good temperature that will actually melt the aluminum. Pouring temperature is around 1400 degrees. Then you place the pattern in the bottom half of the mold against a board. The bottom half is called a drag. And in order to keep the pattern from sticking to the sand around it, you dust it with parting compound. Historically, parting compound can be anything that, like talc, which is the industrial name for it, but also wood ash will do, or in my case, I'm cheaping out and using baby powder because it's what I had on hand. A light dusting is all that you need, and you don't want excess because that would contaminate the sand. Ideally, you would pour the sand through a riddle, which is a screen to break up the big clumps. I'm just doing it by hand because I didn't have one at the time, and then lightly pressing it onto the pattern to help form it into the contours of the letters. After that, it's just a matter of filling up the entire flask with sand, and that takes a good long while, so let's not be here all day, shall we? Right, when that finally starts to get done, you need to compress the sand so that it will actually stick around things. You do that with a rammer. Now, in my case, I'm using a chair leg. Again, this is very hobbyist, but the idea stays the same. You press it down very rapidly with strikes by the blunt end of the rammer to get the sand to actually hold its form. After you're done with that, you need to strike it off so that it is a flat surface. Obviously, when you strike it off the first time, unless you were very excessive with how much you filled the flask, there will be some remaining, so sometimes it takes 2 or even 3 iterations of filling up with sand, ramming it down, and then striking off again. For the final strike off, you're looking for a completely flat surface on the bottom. So I go back and forth a few times and I make a sawing motion with the stick to get a flat surface as much as possible. Now that makes little bits of sand on the edges stick. So going back and forth is key to actually getting a surface that is flush with the bottom of the flask. That way when you roll it over, it won't collapse at all. Rolling over is the second most stressful process in casting. We'll get to the most stressful one later. The point is you need to flip the whole thing over without disturbing the sand to get the other side of the pattern up. And since I'll be putting it back down on this same board, I need to take the time to clean all the sand off that would be holding it not level, because I need that to be sitting flat. What a smarter man would have done is rolled it over onto one of the flat sides so that I didn't have to deal with the protrusion that is the alignment feature, but, well, here we are. A liberal dusting of parting compound needs to go between the two halves, because otherwise when you ram up the top half, the cope, it will stick to the sand in the drag. By using parting compound, it will separate cleanly. A thin dusting is all you need, again, but it needs to be evenly spread, so using a small brush to get it evenly around everything is key here. Aligning the cope half, the next thing that goes in are a riser and a sprue. The sprue is what the metal gets poured into. The riser is something on the other side to continually feed metal into the pattern as it cools. The empty space left by when the pattern is removed in the sand is going to shrink as it cools. What the riser does is provide more metal to it to keep it from shrinking too much and forming voids. Again, ideally I would have riddled that sand, meaning broken it up through a screen, but once more, by hand is good enough for my application. And then I just pack it around the two pipes that I'm using to mold the sprue and the riser. Again, ramming up, I'm flipping the ramming tool over to get in really close around those two pipes, and then ramming continuously around everywhere else. Once again, it winds up being below the surface of the flask, so I have to add more sand and ram again in order to actually get something level. And finally, the sprue and riser are removed. The riser can get wiggled around a little bit, but the sprue, ideally, you want to pull straight out so that none of the sides are damaged at all. So you should be able to twist and then pull. Now, the pipe that I was using has a bit of an out-of-round complication at the end, so I had some difficulty with this, and that may have weakened the cope as a result. Some folk like striking off with the sprue and riser pipes still intact so that they can't knock sand anywhere, but it's much easier just to dust the sprue and riser with parting compound. That way, by putting that in there and then blowing it around so it sticks to the sides, you don't have to worry about any of the sand that falls in, because it will happen anyway, sticking. Any sand that is loose in the mold will wind up being an inclusion in the finished part. Once again, striking off, this time going across the midline of the holes to mitigate as much of the sand going in as possible. And then back and forth a few times to get a truly flat surface. Using a small brush to round the edges makes it so that sand won't fall in from those sharp corners. Sharp corners are inherently weak no matter what you're designing, and sand is certainly no exception. That just puts a slight radius on them and makes everything go a lot smoother. Now, this next part is completely optional. I happen to have a crucible with a very wide lip, so it's difficult to pour accurately. So what I'm doing is making a casting basin, something to pour into while I aim for that tiny little sprue so that I don't spill molten metal all over everything. And well, you can see from that flask that it's taken some abuse in the past. Burn marks are an unfortunate part of this sort of thing. The wonderful part about sand casting is that you can alter the sand as you need. Having a solid piece to form around is not necessary. Just remember that every time you alter sand, you have to press it back down again so nothing loose remains. Now the final step is using a piece of wire to form vents. Steam will be generated when you pour molten metal into sand mixed with water, so the steam needs somewhere to go, otherwise the entire thing just becomes weaker or makes bubbles in the surface of the finished metal part. So using a vent wire takes care of that. Now I mentioned earlier that this flipping over of half of it was the second most stressful part. Yeah, this right here is the most stressful part by far. Taking the top half, the cope, off and then setting it aside without it totally collapsing on you is absolutely mind-numbingly terrifying until you get used to it. I have had it collapse on me more than once. Having a couple of holes in the pattern to draw it out with is completely necessary, and I had a little bit of sand fall into mine, so I used the vent wire to scoop that out before putting a couple of screws in. And then by wrapping the pattern, you enlarge the cavity that it made a little bit so that it pulls out more easily. The dimensional accuracy is not usually something to be worried about, but having everything stay where it should be is something to be worried about. You can see in a moment when I draw this out, it comes out almost completely cleanly. However, there's one little bit where that first letter C collapsed. That sand is stuck in there, it's not going back in, I'm never going to be able to recreate that. The only thing I can do if I don't want to just scuff the whole thing and restart is press it back in, so that it doesn't form loose particles in the finished casting. After that, you need to create the gates between the sprue and the pattern and the riser. Now, the mold here is in the shape of the finished part, and I had something to mold the sprue and riser around, but the channel that the molten metal goes through, it's silly to try to mold, so you just scoop out what you don't need. The next part requires a lot of careful dexterity because it is reuniting the two halves of the flask filled with sand, the cope and the drag. The top half has to be flipped back over onto the drag. It all needs to line up and everything needs to stay in place. The very, very, very last thing you want to have happen at this point is for something to totally collapse out of the box containing it right now. If you need me, I'll be in my backwoods screaming like a banshee. Anyway, I took one from the cooking show and prepared this off screen. The only difference this time was I placed the pattern diagonally instead of straight across. That way I had a little bit more room for the sprue and riser. I just shut the gas off on the furnace, and right now I'm getting ready to extract the crucible. Now before I can do that, there's a whole bunch of molten aluminum in here, and any impurities in the aluminum will have risen to the surface, so they need to be scooped out. That stuff is called slag or dross, and if that got into your casting, that would give you a bad time. So removing as much as you can is a very good idea. I'm just using a piece of angle iron here. Probably using steel in molten aluminum will corrupt the metal a little bit, but not enough to make any noticeable difference for me. Believe it or not, compared to pattern making, pouring, once you get used to it, is the less stressful part of this. Now, you are working with molten metal, so full leather is needed. And ideally, best footwear possible. And oh, that's warm. Watch your shoes, there's molten metal on the ground, and oh dear. No, it's fine, no one's on fire. Don't worry. All joking aside, the serious part here is making sure that the sprue is continually filled to the brim with metal for the entire duration of the pour until you see it coming up the riser. Now, you do not want anything to cool in the crucible, so any remaining metal has to be poured out. I'm using a muffin tin as an ingot mold so that it can be in little manageable sizes. And then just to cool off safely, I'm going to put the crucible back into the foundry furnace. And about 15 minutes later, we are ready to shake out the casting and see what's inside. Now I'm just dumping everything right back into the bin. I'm going to break up the chunks later and re-water the sand so that it is not too dry, because some of the water will have escaped to steam. Yes, full leather is still necessary right now, because that thing, although not glowing red, is still going to be very, very toasty. It's just not a good day for me for sand now, is it? And then we're going to skip the part where I spend 2 minutes trying to fish a pair of vice grips out of my pocket. Anyway, here's the finished part. Now, since sand is stuck to everything right now, a steel wire brush to knock off the excess before it completely cools just makes everything a lot easier to clean up later. Night fell between the time that I poured and the time that it cooled, so let's go back inside and take a look at the finished product. So from the first round, we came up with this. Now, I will readily admit, the sand I was using was way too dry. I should have stopped immediately and retempered it, and I realized that almost immediately, but gosh darn it, I wanted to get through that project. So I used sand that was too dry, and my surface finish definitely suffered as a result. I also had many more sand inclusions, little pockets like that are actually sand embedded in the casting. So in order for this to be shippable, that would have to be blended out somehow. Also, I had a bit of collapsing in one of the letters. That was from when the pattern was drawn out of the mold. The sand itself partially bonded to the U as it was drawn out, and so the remainder, yeah. These marks here are from when I put this in a vise to show that castings are more prone to brittle failure than any other types of metal you may have worked with so far. Some other casting flaws in this thing, apart from the absolutely despicable surface finish because I was using sand that was way too rough, that's on my to-do list to fix this weekend, was there is a void. That is a missing amount of material just because the metal didn't flow in there for some reason. There are many sand inclusions. Also, the back surface of this thing is the opposite of flat. It contours around itself, and the reason for that was I rammed up a empty drag first, that iteration, put this down on the drag, and then rammed the cope over it, and so this was in the cope half. So the top of the pour was over here where the sprue used to be, which I knocked off in the hey, this is brittle demonstration. That fit right there. Now, since I did not have a completely level surface in the sand, when I put the pattern down on it, that is all of the irregularities that were in the surface that I put the pattern on. Time number 2, I did it the right way and actually put this on a molding board, rammed the drag up over it, which is the bottom half, then rolled it over and rammed the cope up over the flat section. Came out with many fewer inclusions and also a much flatter underside. I also wound up using a larger riser. That probably helped with some of the voids, but more than anything else, I rammed a lot harder, and I also moistened the sand a bit so it was a lot wetter. Now, I still wound up with a little bit of sand in the C, stuck in the C, the first C of the pattern, when I pulled the thing out. And that happened twice. Other flaws in both of these, to varying degrees, are here's a little bit of flashing. Flashing is when a little bit of metal gets in between the two halves at the parting line, where the cope and the drag separate. Same thing can be seen in the second one. Now in the real world, in order to make this a shippable product, I would have just stopped and redone this the second I pulled the pattern out with that going on, because that would take some milling to fix. All of these would be blended, the sprue and the riser would get hacked off, and that blended flush. Oftentimes casting are blasted, either bead blasted, grit blasted, anything to give it a uniform finish, and even aerospace allows for weld repair on most castings. Even this is like uber controlled vacuum cast in a permanent mold titanium castings. So situations like that you could fill it in with weld and it would still be acceptable within a certain limit. Now, as far as the overall porosity goes, when you're designing for castings, assume that this is going to happen. Assume that you're going to get little pits and everything. Make it so that you have extra stock to remove by machining operations on any surface that is in contact with something else that you really care about. Overall, these came out about as well as I thought they would. I am still a complete newbie at this. I've only done a few castings myself. Adrian has done most of the rest, and he is partway through making a shaper at this point. All the components you see here were cast in my driveway and machined in his basement. That's just a personal project he's working on. I'm planning on getting into the same sort of thing, so stay tuned if you are interested and you can watch me learn. Things that could be done to improve this is definitely finer sand so that I wind up with a better surface texture, sand that is properly tempered, because the right moisture level is absolutely critical to make sure that you have as few sand inclusions as possible so the sand's not falling into the empty space and then becoming permanently bonded into the aluminum. Yeah, a few of those are never going to come out. But also a lot of it is just experience. If you want to see someone who is actually good at this sort of thing, this is an image of a casting made by Olfoundryman on YouTube. Link to the video that this came from in the description if you'd like to see someone do this who has been at this longer than I've been alive, almost twice over, and knows a thing or two about it. Well, best of luck to you all. I hope you found this informative and a little bit entertaining. I am going to return these to my garage and get on with the grading that I've been putting off for way too long.